Hey guys, so 4.4 logarithmic functions. So in general, a log and an exponent are inverses of each other, right? So we talked about that. And I like to say that the answer to a log is the exponent. So again, the answer to the log is the power. So when you do log base a of x and you get y, that means that a to the y power, so the base is a to the y power equals x. So you're always thinking, how do I get x if I have a as a base? And then you're wondering in your head, what's my power? That's your power. So the answer to the log is the exponent. Okay, so this is how it's written in exponential form. And then we talk about that a little bit more later. Some log properties that we went through really quickly, so I'm just going to show you all of them at once, is log base b of 1 is 0 because b to the power of anything actually to the power of 0 is 1. And then anything to the power of 1 is itself. And then we also have log base b of x to the x power. That x can come forward with the power rule for logs, and then log base b of b is 1, so really you have x times 1, which is x. This is a property of logs, so b to the power of log base b of x is x, and then this is the same thing as this, except this is a log base e of e to the power of k, which is k. So log base b to the of b is 1, so log base e of e is also 1. So ln e is actually 1, and the k comes forward, k times 1 is k. And then this is very similar to this one. So e to the power of, technically this is log base e of k, so my property tells me that I can go ahead and simplify, and that just becomes k. All right, so a couple examples. So how would you change something like this into log form? So there's a couple ways that you can do this. So up here, a lot of people use like this loop method, and they'll be like, oh, a to the power of y is x, and then they like unloop it or whatever. So I don't really like to do that. I like to use this fact and this fact. So basically, if something doesn't have logs and I want to make it into a log, I can log both sides, and I just use my base. So when I log both sides, I do log base 1.2 and then log base 1.2. This becomes a 1, right? The 3 comes forward, and then you get 3 equals, can I move it? Yes. 3 equals log base 1.2 of x. So I just wrote it in another direction, but I put the 3 equals log base 1.2 of x. So I like to do it that way so that I can really see what I'm doing, okay? Same with this one. So for this one, it's log base 4 of x squared equals 5. I'm changing this into exponential form. So what I want to do, it already has a log, so I can't log both sides. Instead, I want to raise both using the same base. So I'm doing this method. So basically right now I have something like that, and I want to be like, oh, I want there to be a b to the power. So then I used a 4, because then I can do 4 to the power, 4 to the power, and then this is my log property, and just becomes x squared. So x squared equals 4 to the 5th power. Okay, so if I were going to write that into exponential form, I would just do that. Okay, this one, you're thinking in your head, how do I get a 3 to become a 1 over 81? Well, when you go to the bottom, it's going to be a negative power, right? And then how do you get a 3 to be an 81? Well, it's 3 squared, which is 9, 9 squared, which is 81, so it's going to be 3 to the 4th power. So I rewrote it like this first, so you can see what I'm really trying to do is get that log base 3 of 3, which is 1, and then that power, if I think about this part, is, oh, this is actually 3 to the negative 4 power. The power comes forward, and then times 1 is negative 4. So same idea for this one. This one's a little crazy looking, but if I want to simplify this, what I want to focus on first is this piece in here. So how can I rewrite 0.5 to make it into a 2 to the something power, because that's what I want, right? This is 3, base 3, and then 3 to the something. This is base 2. I want this to be 2 to the something power. So I'll kind of show you my work because we already talked through this one. So you know that 0.5 is 1/2, and then you can rewrite that as 2 to the negative 1 power. We can think of it like that, 2 to the negative 1 power, and then to the power of x cubed is going to be just that negative x cubed. Okay, exponents versus logs in terms of graphing. So I made this one on the left side yellow, and then I went ahead and I graphed it. So we can do that. That's not a problem. Okay, we've been doing that. So for the orange one, for the log graph, I went like this. So first, I changed my log. So we'll ignore this part for now, okay? I changed my log into an exponential. So this is y equals log base 2 of x. So it becomes 2 to the power of y equals x. Or I can think, oh, if this is, y equals, then I can do 2 to the power, 2 to the power. And then again, I get x equals, and then 2 to the power of y. So I get that. So from here, I do my xy. The difference is going to be, instead of using my x values as -1, 0, and 1, I can now use my y values as -1, 0, and 1. Plug that in to get x values because these are inverses of each other, right? So once I do that, I can go ahead and graph it. And then I'm keeping in mind my yellow graph, my exponential graph, has a horizontal asymptote, which means that my inverse is going to have a vertical asymptote, my inverse graph. Okay. I don't think that we labeled this in the notes. Can you make sure that you label it right now? So this is your y equals 2 to the power. This is your y equals log base 2 of x, okay? And then just looking at the graph, you can see why this would be true. So the domain of the yellow one goes all the way. There's a horizontal asymptote that we drew together in class. And then the domain of the orange one starts at 0, but there's an asymptote at 0, so it goes to the right. So from 0 to infinity. And then the domains and ranges are switched, right, for inverses. And then your y-intercepts, instead of a 0, 1, this is a 1, 0. See, 1, 0. Instead of a horizontal asymptote, now you have a vertical asymptote. And then they're both, these specifically, increasing. So this is going up, up, up. This is also going up, 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 but very slowly. Okay? All right. So how do you graph? Well, actually, we don't start with graphing. So I started a little bit with, actually, right here, I'm going to just say, the domain of a log function is, if you were going to maybe start that off with, the domain of a log function is, talk about inverses, think about it, it would be the range of an exponential function, right? Because domains and ranges of inverses are going to flip. To find a horizontal asymptote of an exponential, we look at y equals, which means for vertical asymptote, for log functions, it's x equals. So we talked about that in class as well. And then find the domain. Okay, so every class did different problems. So I'm going to go through each one. So let's say you have something like this. So find the domain. So if you're finding the domain here, I know that for logs, I really care about the vertical asymptote, and then I'm going to be either to the right of that or to the left of that. Because the domain, remember on the front, the domain, this one was to the right of the 0. But then if there was like a negative somewhere, then it might be to the left of 0, right? It just kind of depends. So what I really care about is the x equals. So I look at this and I go, okay, well, what could x equal really? So right here, you have log base 2 of something. So I'm going to write this down so that you can kind of see it. But if you have log base 2 of something, I'm going to put just like an empty space, okay? What goes there and what can't go there? So in class, we were saying that basically what cannot go in here is a 0, because 2 to the power of something will never give you 0. That's not possible. Can you think of any number? 2 to the power of 0 gives you 1. Nope, doesn't work. 2 to the power of negative 1 gives you 1 over 2. So you're never going to get 0. That's not possible. Something else that we will never get is basically a negative number. So any negative number won't happen either. No matter what you take the power of, put it in your calculator. 2 to the any power, you're never going to get a negative. So that's why here I wrote that this has to be positive. So not greater or equal to 0, but actually greater than 0. So then you solve for x, and then you have your domain. And when you graph it, you'll see that this is true. This is your vertical asymptote, x equals -3, and then everything will go to the right of that graph. Okay, the next one is a little bit different looking. So something like that. So again, this part, we want it to be greater or equal to 0, but because this is already absolute value makes it so that it's like positive, right? So we don't need that part that says greater. We can just say, oh, x does not equal 0. Because even if x is negative, when we plug it in, then the absolute value will make it positive. So we're okay. So x is not equal 0. All right. So then our domain is just, you know, skipping over the 0. Done. All right. The last one is the trickiest one. So this one we talked about in class, but we still want this to be greater than 0. So that's my first step. I'm going to say that is greater than 0. And then, oops, uncovered. So, and then I need to think, okay, well, where does the 0 happen, right? Because that's what I really care about. Where does the 0 happen? The 0 would happen at -3, but then I want greater than that, so to the right of that. But then here, where do the zeros happen? Well, on top, if I have a 0, then I have x equals -1. On bottom, if I have a 0, which I can't have, because then it would be undefined, it would be x equals 1. So I make a little number line using the -1 and the 1, and I literally plug in to the left of -1, and then we plugged in between, and we plugged into the right. So use any number. I think we used like a negative, 2, and we plugged it in. -2 plus 1 is negative. -2 minus 1 is negative. A negative divided by a negative is positive. And then we plugged in a 0 because it's a really easy number between -1 and 1. So 0 plus 1 is 1, 0 minus 1 is -1, 1 divided by -1 is negative. And then on the right side, you can plug in anything you want. You can plug in like a 10. 10 plus 1, 10 minus 1, positive divided by positive is positive. We want positive answers, which means that we want this portion and this portion. How do we write that? Negative infinity to -1, and then skip over this whole thing from 1 to infinity. So that's our domain. If you put this into a graphing calculator, it's possible, you can actually do it. You'll see that to the left of -1 stuff happens, and to the right of 1 there's going to be some graph. Okay, so how do you graph a log function? We did one of them together. So basically we changed to an exponential. So first of all, you need a parent function, and then you change to an exponential, and then you do the 3 y values, -1, 1, and 1. So the first one we did not do together. So here's your first one. Actually, I'm going to flip this so that thing's not there anymore. Okay, so here's your first one, and then you have the -3 in front. You have log, it's missing a base. We'll talk about that in a second. And then x minus 1 in parentheses, and then plus 2. Okay. So what base is missing? Well, if a log doesn't have a base, what's missing is a 10. So that's a common log. So really, we're supposed to have a little 10 here. And then the first question is, what is the parent function? So the parent function is y equals, and then you just look at the basic one, okay, right here. So it's going to be a log base 10 of x. So I write my parent function first. So my parent graph is going to be this. I change it into an exponential, so 10 to the power of y equals x, or I can even do 10 to the power, 10 to the power, cross, and I get 10 to the power of y equals x still. So I still get this. Okay, so I'm going to leave it alone on the right side. I'm just going to cover this up. And then I start with my negative, and then my 3, and then my -1, and then my 2. So 1, 2, 3, 4 transformations. So 1, this is a reflection over the x-axis. It changes my y. Number 2, that's a vertical stretch, 3y. Number 3, horizontal shift, x is y. And number 4, vertical shift, y plus 2. Okay, and then I always like to put this, but you can always do it later if you want. I like to put the vertical asymptote. The vertical asymptote is x equals 1. So basically I'm solving for 0 in here, kind of like what I did over here. But except for, instead of domain, I'm just saying, okay, what does it not equal? So x equals -1 is what I cannot have. I can't have a 0 here because that's not possible. Okay, so then I do my little -1, 0, and 1 for my y values, and then I plug in to here to get my x values, and then I go through 1, 2, 3, 4, and eventually I get this. Right, so I start off with -1, 0, 1, and then I changed all my positives and negatives to opposites. And then this was a 1/10, 1, and 10. And then my next step here, after I change these positives and negatives, I multiplied by 3. And then I added 1 to all of these. And then I added 2 to all of these. Okay, so I'm done with all 4 steps. And then there's a problem. There's a slight problem. It's this stupid number over here. That's the problem. That's too big for my graph. So my graph is going to go by 2's. So just be careful when you graph. When you go by 2's, make sure you know that you're going by 2's. So you can do that just by putting a little 2 here and a little 2 here. I would always start with my vertical asymptote. And then I just graph all my points. And then this still goes out a little bit. It's okay. If you go out by like 1 unit, it's okay. But any more than that, and you have to, you have to scale even more. Instead of 2's, maybe a 3, 4, 5, whatever you need to do. Okay? But make sure it's scaled. Don't put like a 1, 2, and then like a 10. You can't do that. Okay? So something like this is your graph. And then I think we did this one together, or at least we started it together. But let's say you have y equals ln. You're going to start with parent graph. What's the parent graph? Log base e. So then I have my parent graph, and then I change it to an exponential. And then, I'm going to cover this for a second. We said we had 1, 2, 3 transformations in class, but some of them we didn't do all of them. So the first one is a stretch because x is lie. And then the second one was a horizontal shift. Again, x is lie. And then a vertical shift, y plus 1. Okay, what is your vertical asymptote? Your vertical asymptote, what can't x be? I need it to not be a 0 in here. Oh, okay, vertical asymptote x equals 3. Because if x is 3, then I would get a 0 in here, which is not okay. All right, so then you go ahead and I'll show you my work for this. Plug in. I did something a little different in class, so I put 1 over e. 1 over e is about 2/3, or sorry, 1/3, and then I changed this to about 2/3. Notice 2/3 and this is a little bit different, right? That's okay. That's not a big deal. So if you if this was 1/3 and this was 2/3, then this would be 3.7, I think. But 3.7 and 3.8, on a graph, it's about the same. So don't worry about it, okay? So we started off with -1, 0, and 1. This was 1 over e, 1, and this is e. And then times 2, and then plus 3, and then plus 1. And then my final x's and y's. Again, this 8.4, man, I gotta go by 2's. So I went by 2's. Just try to be careful here and don't go over. Like if you go over a little bit, it's fine. If it's a little squiggly, it's fine. Mine's a little squiggly. But just don't go like all the way over here, right? Because then I'm like, oh, no, you definitely forgot about the vertical asymptote, or you definitely don't understand what a vertical asymptote is. Okay, the last two I love, love, love. Okay. So solving log functions. You're going to do it differently depending on the problem, but let's say you have something like this. Oh, I need an equals. Equals 2. So let's say you have something like this. So just like on the other page, I would, instead of, so I want to solve for x, right? I need to get the x out of the log. I need to change it into exponential, so no more logs. To change it into exponential, I would do 3 to the power, 3 to the power. Do you have to do that? No, but I like to do that so that I can just go ahead and use my property and say this is equivalent to 4x minus 7. And 4x minus 7 equals 3 squared. And then I just go from there and I get my final answer. Don't forget to check your answer. So when you check your answer, it's actually really quick to check these logs. 4 times 4 is 16. 16 minus 7 is 9. Log base 3 of 9, is that 2? It is, because 3 squared is 9. So that works. Okay? Okay, here's your other one. Let's say you have something like this. So again, I'm solving for x. I want that x to come down. So I can't do anything with it like this. So what I'm going to do is I have to log both sides. But I can only log both sides if I have just one number here. An e is a number, that's okay. But this 10 is in the way. So first, divide by 10. And then now I can do log base. I want to do log base e. So I just use ln. So ln both sides. And then now on the left side, I just have my 2 times the quantity. On my right side, I have an ln of 1/2. And then I keep going and I solve for x. So multiply it out, solve for x. Okay, this is one answer. This is one answer. But I want you to keep going and I want you to see what you can do with logs. And it's been a while. I know it's been a while. But if you keep going, what you can do is you can put that 1/2 in front of the ln, right? Because when you divide by 2, it's actually multiplying by 1/2. So that's all I did for that step. And then if I keep going, this will look like this. This will, if I were to rewrite this as a power, oh, I didn't even rewrite it as a power. If I were to write this as a 2, it would be a 2 to the -1 power. So that's why the negative comes forward, and then you get a -1/2 ln to 2 minus 3. There's so many different ways to write the same answer. These are equivalent. One is not necessarily better than the other. This one kind of sucks because it's a fraction and a fraction. So I'm going to say it kind of sucks. I would never leave it like that. This is acceptable. This is acceptable. I'm going to show you something else. Technically, this can also be written as ln of 1/2 to the power of 1/2, because the 1/2 can go up there, right? So it can become a power minus 3, which is ln of, this is a square root of 1/2, which is root 2 over 2 minus 3. Is this acceptable? Sure, it's acceptable. Normally you're going to see something like this, and then we'll see why this is better after we do the next section. But this is not a wrong answer. This is not a wrong answer. This is just like the best looking one, that's all. So as long as you can get to wherever, you know, we want you to get to. If it's multiple choice, you're not going to be given all 3 of these choices. You're going to be given 1 correct choice and 3 incorrect choices. So you just got to get to the 1 correct choice. All right, good luck. I'll see you later.